everyone. Thank you for having me. Usually when I do this presentation outside of a dedicated service mesh community, it takes me much longer time because most people don't actually understand what service mesh is. So I have to start with some introductions, but I'm going to skip all the introductions for this specific meetup and this specific talk. So the content, I don't have actually a lot of content. It's more like a distilled experience of a couple of years implementing certain service mesh in certain projects. But I want to make this as interactive as possible. So if you have any questions, just please feel free to ask them in the chat. So the title of the talk is quite provocative, and the idea here is to really make people cautious about implementing service mesh in general. And I also modified it to make it specific to Istio, because different service mesh does things different ways. But pretty much all the learnings from this talk really are applied to pretty much any implementation or any cloud products, to be honest. So I'm a cloud developer advocate at Google. I've been doing before this a couple of years or 5 years of consulting as part of something called PSO, Professional Services. So where we work directly with external customers of all sorts, from startups to big tech companies to banks and financial institutions, helping them implementing things. I did quite a lot of GKE and service mesh, so the Google managed offering for Kubernetes. And overall, I did quite a lot of infrastructure experience, right? And usually when we talk to customers or we talk to people about service mesh, this kind of tends to be the slide that we use it to sell the technology, the benefits of a service mesh, right? Like the fact that it allows you to connect a bunch of microservices in a flexible way, secure the communication between these microservices, control the policies between these microservices. So basically control both policies in terms of who can do what and who can talk to what, but also control the traffic between these policies and these microservices, and then observe by getting a bunch of metrics and traces from this communication and dump it somewhere. And I think what we don't think about too much is the drawbacks, the actually why not, the things you have to keep in mind. And I try to organize these things into 4 main categories. Think about them as like incremental steps into, I want to go from I don't have a service mesh to now I have a service mesh. What are the 4 main things I need to keep in mind, right? And so the first 4 main thing is the capacity and resources. A service mesh data plane and the service mesh control plane does consume CPU and memory. So you have to keep that in mind. I have seen implementations where we started with a few 100 pods in a microservice-based environments, and by introducing, to be honest, by introducing earlier version of Istio have improved drastically in the last few years, or I would even say the last few releases. But before, it used to consume lots of resources. It still does. It's not cheap, but I have seen situations where by introducing a service mesh, we managed to get to a point where the service mesh sidecars actually consume more resources than the actual application. And here I'm talking specifically about sidecar-based service mesh like Istio. They do introduce some network latency. That's because there is a proxy, and if you go through proxy, there is latency in the network that you have to keep in mind and accommodate. They do come with some design decision and architecture decision that you have to sort of take on day one. There are certain things that if you implement a service mesh with, you can't just change them. Like most tools are not as flexible as most people think they are. And then once you deploy your service mesh and start using it, it will start generating a bunch of data and a bunch of metrics and logs and stuff. And you need to deploy extra software to take advantage of those extra things that are available to you, right? And so that's what I call the auxiliary infrastructure. So that's basically software that you have to deploy and maintain and manage, etc., etc. So let's start with the capacity and resources. This is kind of straightforward, I guess, for a lot of people. Sidecars are containers. Containers need CPU and memory to run, right? I just pulled some numbers from the last benchmark that Istio have released. For 1,000 services, which means 2,000 sidecars and 70,000 mesh-wide requests per second, so 70,000 RPS. With 1.14, the last release, the Envoy proxy consumes approximately 0.35 vCPU and 40 megabytes of memory per 1,000 requests per second. Now, put this way, it might seem like not a lot, but in my opinion, 0.35 CPU for 1,000 requests per second is quite high. So if your services are not very chatty, you're probably going to be okay, and you're going to probably be fine paying almost half a CPU and 40 megabytes of memory to have MTLS handled for you by the service mesh. But once you start scaling up your application, both in terms of the number of total pods you run in your cluster and also in terms of the amount of traffic you're handling, well, that footprint will start increasing. And you have to basically keep in mind, both from the perspective of it costs money, but also from the perspective of capacity planning. As you all probably know, most of service mesh implementations are done in cloud, and cloud is not unlimited. Like, right, stockouts are very common. People not being able to provision virtual machines is a very common thing in most cloud providers. Different cloud providers are doing different things to try to handle it, but it's something you have to keep in mind. Istio itself consumes 1 vCPU and 1.5 gigabytes of memory, which is not a lot, but if you have a big mesh, you will probably need to horizontally scale Istio, and that could also cost money, right? So that's the first thing. The network latency. Now, I mean, some people might argue that 1.7 milliseconds and 2.7 at the 90 and 99 percentile latency is not a lot. That's probably not a lot, but it really depends on the application. It really depends on how responsive the app have to be. So if you have a proxy, you will have latency. That's just a fact, right? There is no way around it. Now, I have seen some sort of new or about to be either already released or about to be released implementations in different service mesh, other service mesh tools, not Istio, trying to mitigate this by moving either to eBPF or by moving to eBPF for certain functions, or by deploying a proxy at the node level. Those are all good efforts to try to reduce latency overall and reduce footprints, but they come also with a drawback. If you do a node level proxy, then I bet that most of you who works with customers, the main question that will be raised would be, and by customers here, I mean, like, non-tech savvy customers, non-tech savvy companies, like companies that, not necessarily talking about specific industries, but you get what I mean. So once you tell them, oh, we're going to move from a sidecar to a node-based proxy, then the question is, well, how do we secure the communication between the sidecar and the proxy running the node, right? Because that portion is unencrypted in a sidecar-based service mesh. So if you move the proxy far away from the actual pod application, so how do you secure that portion of the traffic? If you move toward eBPF, then the same question comes up, like, how do we secure it? Who is responsible for the eBPF modules as part of the kernel, etc., etc. So these are all, like, there are good efforts. I think what I'm trying to say is there are good efforts to try to mitigate both the resource footprint and the network latency problem, but they come with some drawbacks, and you have to basically be ready to answer these questions. Design and architecture. I took here the most extreme case, in my opinion, that I came across. There are many other cases where, like, you have to decide on day 0 before you even implement service mesh, how is your target architecture gonna be, or gonna look like, right? As much as we want to believe that people who are doing cloud are flexible in terms of, oh yeah, I mean, if the architecture on day 0 was not the right one, then we're just gonna, delete everything and then create it again, because, ephemeral infrastructure, and that's what cloud allows you to do. As much as we want that to be true, that's not necessarily true all the time. A lot of people, a lot of customers tend to think about cloud infrastructure as a static over time. And for them, deleting everything and rebuilding it from scratch because they have made a wrong architecture and design decision on day 0 is probably not even an option on the table, right? So the extreme case that I came across was doing a multi-cluster implementation, so multi-region implementation with clusters span across multiple regions on the same VPC, specifically Google Cloud, but I think it's kind of the same for all the other cloud providers. You can, like, these kind of things, you can just choose, and to be fair, we did it with the remote control plane, which is not supported anymore in Istio. So these kind of decisions, you have to choose them from day one. You can just switch things around just like that, right? Like there are certain decisions that you have to keep in mind and you have to take from day one. And one of them mainly is the multi-cluster sort of multi-control plane or single cluster, single control plane type decision. It became easier slightly with Istio recently, but it's not, and this becomes even problematic later on if you want to introduce, you know, hybrid connectivity with on-prem and cloud, or yeah, and all the other things I talked about before, the resource footprint, the latency, etc., is a factor in this design decision, right? Because the farther you have to shoot packets around regions, the more latency you're going to have. The last one is the auxiliary infrastructure. I have a couple of more things I want to talk about, but the one thing is the auxiliary infrastructure. The way I like to think about it is that a service mesh doesn't live in a vacuum. You need to run it on top of a cluster, specifically Istio, and you need to deploy a bunch of extra software to be able to take advantage of all the things the service mesh gives you. Like tracing, monitoring and logging, the graph interface, the GUI to get the graph, etc., etc. So these are all software you have to deploy. I know that if some people are in this call from the Istio community, they might argue that we made it easy in Istio to deploy these things. Yes, we did. But deploying something from the command line and running it in production are two different things, right? So these are all interesting, like, pieces of infrastructure that you will have to deploy, maintain, fix, patch, etc., etc. So so yeah, so keep that in mind. It's not like, hey, here is a service mesh, deploy it, put a bunch of labels, magic, everything just works, right? So in a nutshell, I told you this is going to be short. In a nutshell, the kind of 5 lessons learned, for me at least, were: do not take a simplest approach. I've seen, especially in some security conscious companies, they just go like, oh, we need security. Can MTLS give us what we need to meet certain security requirements? Yes. Is Istio painful to manage? Sorry, is MTLS painful to manage by hand? Of course it is, especially at scale. Can a service mesh give us MTLS easily? Yes. Okay, let's use it, right? And specifically in this case, what I want to actually mention is this problem is specifically exaggerated if you are working in a distributed environment with some sort of central platform team, which is actually a trend that we are seeing these days, which is one team handling all your central infrastructure, all your central Kubernetes clusters, and all your service mesh, kind of control plane deployment, etc., etc. And the problem we see there is, well, one of the problems I see there is the platform team will run the clusters. They will deploy the service mesh for you. They will label the namespace for you, but you as an end tenant, as a developer, you don't probably even know there is a service mesh, or even if you know, you don't really understand how it works. And then you end up probably implementing certain things manually that in code that exists in the service mesh using a YAML file. So the most kind of extreme case I've seen before is people implementing retries by themselves while they are using a service mesh, and the service mesh can do that for them. Or implementing their own canary deployment using some sort of sophisticated CI/CD pipeline while the service mesh can do that for them, right? So these are all things to keep in consideration. If you end up in a situation where you have to deploy a service mesh in a centralized way, I think you should be able to surface that information to everybody who is involved and let them know that there are things that can be done using a simple YAML file instead of implementing it in code. There is another problem, which is service mesh compatibility with certain applications. I've seen this a couple of times, but I think one of the kind of common use case that you might have came across is using a data transformation pipeline. Sorry. An example that came to mind, that this is not specifically to point out a specific tool, it's just an example, is the Argo pipeline, the Argo, not CD, not the CI/CD pipeline, but the Argo tool that allows you to do data transformation on data. So that the way that works is that you have a control plane that you configure to spin up a pod to run a specific piece of custom code on a specific piece of data. When we introduced a service mesh, well, the problem there became, A, the pod itself for the application takes less time to run than the service mesh, than the sidecar. So the sidecar actually takes more time to get up, be ready before the actual application pod can access the network and run and then finish. So basically, like by adding a sidecar, we're extending the runtime of a specific job from few seconds to a minute maybe. And then we're increasing the footprint, obviously. This is not a problem. So for this kind of fast run dynamic environments that are either data transformation or CI/CD or something like that, introducing a sidecar-based service mesh could be a problem. The other problem I think you're aware of is the ordering in which things start. You have to create dependency between your actual application pod or container and the sidecar container so that your application container does not try to connect to the network or resolve some DNS or something before the sidecar is actually available. So basically this problem of whether my application can run with the service mesh in a nice way is a problem you have to figure out before you actually commit to using a service mesh. The example I gave earlier, we just end up excluding the Argo pipelines from the service mesh because it was not compatible, but that's just one example, as I said. In large organizations, one of the problems I've came across is people having theoretical and practical experience, especially in debugging. Because one thing is deploying and labeling and having sidecar injection working and all those kind of things, which is nice. But when things break, you have to have enough theoretical and practical knowledge to know how to debug them, right? And I have spent countless hours in front of the terminal trying to figure out why certain things didn't work. Istio specifically, Istio-CTL, the command line makes that slightly easier. But when you are trying to debug Istio using the Istio-CTL, you have to understand what are you looking at, especially when you use the proxy status or whatever subcommand line that tells you how the mesh is working. You have to understand these like terminologies. You have to understand them properly to understand why something is broken. And this again is another problem that is exaggerated if you are working in a distributed environment, like in a central multi-tenant environment. So the question is, who is responsible to debug and fix the service mesh when it breaks? Implementing service mesh will increase your technical depth, regardless of whether you want or not, because simply you have to maintain, monitor, and manage the service mesh itself, and maintain all the other components I talked about, the auxiliary infrastructure, if you want, anyway. And it will increase your operational complexity for sure, because you are having another layer of abstraction, which makes things slightly more complicated. I have written an article which goes slightly more into details. This is quite old. It's from January this year. You can find it on my Medium blog, and it goes into more details about the stuff I talked about. So you can feel free to read it if you want. And with that, I'd say thank you very much for having me. And if you have any questions.